In this work, the focus is on extending the capability of a given partial 3D scene graph G', in which objects of a set C, relevant for a robotic mission, are missing. We establish the novel concept of belief scene graphs as a utility-enhanced extension of a given incomplete scene graph G', by proposing an approach to meaningfully incorporate C as nodes into the 3D scene graph G'. Due to the sheer variability amongst real-life applications, the complete 3D scene graph of any given environment is hard to estimate for a field robot online. Towards this end, we propose a novel graph-based learning methodology for the computation of expectation of finding objects in C, based on correlation information between C and the objects that are part of the given 3D scene graph G'. This enables high-level task planning, based on belief scene graphs, where the set of histograms E' times O' are input to the proposed CC model to output the predicted set of histograms E" times O'. As no repository of 3D scene graphs is available for the training of the novel CC model, we developed a novel methodology for utilizing semantically annotated real-life 3D spaces to generate a 3D scene graphs dataset. The correlation matrices of the predicted data and the ground truth showcase the performance of the CC model for learning the underlying correlations between the different object class labels present in the generated dataset. In addition, the comparison between the input, predicted and ground truth histogram helps to illustrate the capability of the model to predict objects that were not present in the input graph, for instance toilet and desk. We tested our approach in a real civic indoor environment with the goal to contrast belief scene graph expectation with human common sense for unseen objects. The environment consists of a small waiting room, a shared kitchen with dining area, and a meeting room. The objective was for the robot to traverse and generate a 3D scene graph with partial information about the objects present in the scene. This graph was then enhanced using the proposed CC model to draw expectations about other possible objects in the environment that were not part of the ones seen during the experiment. These objects are then added into the graph as blind nodes. A second experimental run is presented in this environment, in which some objects have been added or removed in the rooms. Also, a different route has been taken during this experiment, making the set of unseen objects between both runs different.